Welcome back to the discussion of spatial computing. In next couple of videos, we are going to do two things. First, we'll try to define spatial computing via a set of common questions. And then in another short video, we'll talk about who uses spatial computing, who are the customers and so on. Okay? So that would be the second one. All right. So in terms of thinking about the core questions in spatial computing, a central question which has centuries of history is where am I? Okay. People who navigate in open spaces often have to answer this question. In fact, about 400 years ago, the ships crossing Atlantic Ocean from Europe on way to commerce often had to ask this question, and it was a rather challenging question. They could look at the position of sun or stars to determine roughly their latitude. However, the longitude was very hard to determine, and there was a grand prize. There was a really large financial reward for people to invent equipment to find the longitude of ships. And several different inventors over decades invented these things, and we still benefit from some of those. In fact, the clocks which could work in the ocean with all these motion came out of this particular quest. More recently, we are really lucky to have global positioning system. Many of us use that through smartphone or other devices to locate ourselves. Okay. Another interesting question is what's around us, the context. In geography, people have mapped out many features and properties of the earth, including many consumer relevant features such as clinics or gas stations or automatic teller machines and so on. So again, via smartphone, many of us have probably tried this out. And if once you know your location, you can ask where is the nearest Pizza Hut or gas station and so on. Okay. And once these are now offered through something called location-based services, and in this course we'll come and look under the hood to see what are the computational concepts underlying those. Okay. A third question is situation assessment. Okay. This is something which is really used often by companies and by government. So whenever there is a fluid situation, so try to imagine the aftermath of Hurricane Katrina or Hurricane Rita, right? Or a tornado. The insurance companies and the government, they want to find where people are who need the help, and so on. And oftentimes that information is represented through a map. And there are different kinds of questions we ask. One, we may simply want to know where things are and how they are distributed, which area has a concentration of people which can need a help, and that's just mapping. They may fly an airplane or a UAV, take satellite imagery, have geographers digitized and interpret it, and just create a map every day to see how things are changing. Okay. Sometimes we also summarize those maps, and we, instead of looking at all areas of map, we may have to prioritize. So we may look for hot spots of people and try to send larger help there. Okay. Again, we'll dedicate a week in this course to understand the spatial patterns and statistical foundations underlying those. So continuing on, people also are interested in temporal variation. Sometimes situation changes a lot from day to day or hour to hour. For example, here we are showing you an animation of crime reports in Amsterdam by the hour of the day. And as you can see, the crime pattern changes from night to rush hour to day and so on. And this is of help to police and other people working with crime to manage that. Right? So again, people do change detection, people do either through the days or over centuries. Another example of this is climate change, which is at much larger scale, but people are feeling that over centuries or tens of thousands of years, the climate changes dramatically and it affects human civilization. So again, through different topics, we will see these questions addressed in this course. And finally, geography and spatial data is used for a lot of exploration, which may be basis of science. Okay. For example, we might want to know whether our schools are safe or not. And people often collect a lot of data about environmental quality, the air quality, water quality. They want to know where the hot spots are and are they affecting critical things like schools and so on. Okay. People often generate hypotheses, and we will talk about a very interesting hypothesis that was generated out of maps related to spread of cholera. back in 1800s, people thought cholera was spread through air. They used to have this bad air theory, and the doctors used to wear beaks, on their nose full of spices to protect themselves from air. And about 1854, John Snow made a map of London after a cholera epidemic, and he showed that the locations of deaths of people, they were all around a water pump. And this changed the hypothesis, saying that maybe there is something in the water that causes, that carries cholera. 20 years later, germ theory came, and it's a major revolution in science. So again, these are the other question, and you can, these kind of hypothesis generation can be supported either through databases, what we are calling SDBMS, Spatial Database Management System, where people can go and do what-if queries, or they could be supported through exploratory data analysis of statistical nature, where you find hotspots. Okay. Great. So with this, we hope we gave you a sense of some example questions in the field of spatial computing. And in the following weeks, you will probably see these questions in much more detail, along with the techniques that have been developed so far. And hopefully, as time goes by, you will add to this list of questions, and as well as to the techniques that can be used to answer them. So we'll wrap up this video over here. Next video, we'll come back and talk about the customers. Who are the users who ask these kind of questions in today or in recent years? Thank you.